So in this lesson, we're looking at collinearity. Collinearity, it's quite hard to say, with 3D vectors. Okay, so basically, it's exactly the same as it was for the straight line. So for two lines to be collinear, or two vectors even to be collinear, they must have the same direction, i.e. be parallel. So this is the same as the gradient in with 2D straight lines, and have a common point. So simply, if you drew a line from a point to another point in 3D, the 3 points even or more, would they be a straight line? And from our earlier lesson, we already know that we figure out if vectors are parallel by figuring out if one vector is a multiple of another one. And if that's true, then we know that they do run parallel. So in writing, you say if AB is equal to KBC, then AB is parallel to BC. Okay, so I'm going to try and cement this in with an example because I think examples make things a little bit clearer. So, next question. So we're asked to prove that A, B, and C are collinear. So how we meant to figure that out? This is this would be a type of exam question you might get. So you can start off by making a statement and say, if AB equal to KBC, which is basically what we're saying prove that A, B, and C are collinear. And we can see that this starter one is -5, this was -2, -3, so it's likely that B is going to fall in between these points. So if this is true, then the lines are collinear because they have this common point B here as well. So then they are collinear. So if we can prove this to be true, then we know that we are correct. So first of all, we need to figure out AB. So AB, well, we know that's just going to be the same as the vectors inside it minus the leading vector, the backward vector minus the first vector. So that's just going to be -2, -1, -2, minus what was A, -5, -3, -7. And that is going to be -2 -5 is actually the same as +5, so that's going to be 3. And then -2 -3 is going to be like +2, so that's actually 2. And then -2 -7 is the same as +7, so that's going to be 5. That's AB. What about BC? I'll even do this in a different color to make it even clearer. So BC equal to C minus B. So there we have what was C is 4, 3, 8 minus B, which was -2, -1, -2. So 4 minus -2 is 6. 6 minus -1 is 4. 8 minus -2 is 10. Okay, so now you want to compare these two vectors. So you've got AB down here, and you've got BC over here. So looking at this one, 3 is half as big as 6, 2 is half as big as 4, and 5 is half as big as 10. So what you could write a statement like this that says, write a different color, A, B equals a half of BC, or you could write BC equals 2AB. I tend to like to stick with don't get a fraction, I'd like to stick with whole numbers because it makes it a bit simpler. Okay, and because of this statement here, we can say that AB is parallel to BC and has common points, right, B, therefore collinear. Vectors. Perfect. So just to try and visualize this more, this is the same example before, exactly the same 3 points. I've actually managed to plot it in 3D. So what we're saying when we're looking at collinearity is that do these 3 points, do they make a line that creates, that goes straight through the 4, are they collinear? Right? So these 3 points are collinear. Okay? Because you can see a line goes straight through them, all 3 of them, and it passes through point B.